to Calculus 2 on this glorious Monday, November 7th, 2016, the day before, also known as the day before. Don't forget, I'm sorry? If anyone is listening, don't forget to vote, especially if you are not in the United States. The world is watching. Or Galaxy. Yeah, they'll know this.
Otherwise, I'm running a really wish I was in the Delta Quadrant.
The goal for tonight is to look at least 3 problems before the end of the class and write down the topics, like the top 10 things for the top 10 problems, and then the replacement, hopefully, if the exam is sufficiently spicy. This exam is exam on integration, and before I write anything down, I would like to point out one thing: derivatives. You can use them to check every single problem if you're not lazy, if you care. So when you integrate, and you know that integrals are anti-derivatives, then derivatives will undo what you just did. So before I write anything down, I'm just going to say, if you had integral of x cubed dx, and you solve that as x to the 4 over 4 plus c, you can check that by taking the derivative of, this looks like 11, it's 4, the derivative of x to the 4 over 4, well, plus c, and what you get is derivative, you first copy the constant, then the derivative of this is 4x cubed, plus derivative of c is 0. These guys cancel and you have your x cubed back. So any integral that you see on this exam in 2 days can be checked by simply using the derivative. So if you had a u sub integral, there will be a chain rule that will have to be performed in order for you to figure out whether the problem is right or not. Then if you had to use integration by parts, it would be a product rule, and so on. So there will be a few different things that you would have to do. So before we go over the list, what's for the exam, I would say that this is one of the most important aspects of the test on Wednesday. You can literally, know right after the exam whether you have 100 or 32 or whatever, because you can check each answer by taking the derivative. Now, what is on the test? Well, obviously problems and hopefully your answers. We have to start, even though, right, a u sub, we cannot escape this one. It is in Calculus 1, section 5.5, but you cannot escape this one because many of the integrals and many of the techniques are going the route of manipulate the integral in some way so that you are able to use u sub eventually, especially with trig, especially with partial fraction decomposition. So there is a lot of that there. So u sub. Then we have our by parts. Then we have trig. Then we have trig sub. Then we have partial fraction. So all of these are basic techniques of integration. Now we are skipping that one section that says other techniques of integration because I am not able to give you 2 tools, which is the table of integrals or Mathematica, access to Mathematica, Wolfram Alpha, right? So those are the ones that's the section that we skip. Right after that section, we have the approximation methods, right? So integration by, well, numerical, let's call it numerical. That's where we talked about midpoint, trapezoid, or Simpson. Number 7, improper integrals. Why am I writing this red? I don't know. We are talking two types. We have the type 1 and type 2. One with infinity, right? Type 1 had the infinity in limits, and type 2 had the vertical asymptote somewhere. And then we're also talking about differential equations. Now, all of this can be tested in 3 questions. All of this. 3 questions. Because think about it. Trig sub will have to use trigonometric integral to solve whatever you transform, right? So that will be one question. When you do partial fraction decomposition, you're going to end up with things that you have to use U sub 4. So that takes care of that, right? And then you have the numerical integration, right? Now, each one of any of these could be improper at the same time, right? And within differential equations, I can come up with something reduced by parts. It's 3 problems, is good enough. But I will stretch that over 10 problems, so you can enjoy, your hour, 25 minutes of help. So it's not, all condensed. Partial credit is there, obviously. No formula sheet. You will have to memorize the formula for by parts. If you memorize the trig sub formulas from the book, or you use the triangle method, whatever, I don't hold grudges. Partial fraction decomposition, again, you have to memorize those 4. Now, I did say earlier, and I will repeat this one more time, partial fraction will have 2 problems. One problem will say set up. That one will have multiple variables in terms of maybe 6 or 7, I don't know, A, B, C, D, E, and then, I don't know, R, whatever the next letter is. Wow, not allowed to vote, right? So there will be one that will clearly say set up. So please don't waste calories getting up and asking me, do I have to solve this? Because there will be, that much space to just write the setup. That's what it is, set up. Not solve the system of 8 by 8 equations. The other one will either be 2 or 3 variables. The one that you will actually solve all the way. Partial fraction decomposition, so you will set it up and solve it. Numeric, only one question. Now, whether it's going to be midpoint, trapezoid, Simpson, again, you are memorizing those formulas. So this is the one where you are actually memorizing how many formulas? Let's go. By parts, you have a trig sub procedure. You have those 4 set up for partial fractions. You have 3 formulas for numerics, right? Midpoint, trapezoid, Simpson. And then for differential equations, you might want to memorize, or you don't, I don't know, the linear equation for the solution to the linear differential equation of the first order. So that will be like 10 formulas. I did not count trig identities, which you are supposed to know coming into this class, which involve power reducing for sine and cosine, Pythagorean identities between let's say secant, tangent, or sine and cosine, and so on. There could be easily another 10 formulas, 15 formulas in the trig world that could be useful for obviously all the SOHCAHTOA stuff and so on.
I'm sorry, I thought you said there was something in there that you would not be putting in, or did I mishear you?
What I'm not going to put on the exam is the integral of secant cubed, definitely. That's the so now it's live on the stream, because that one is taking way too long. That it's just It's like a PhD thesis to solve that one, all right? It's not. But I like to exaggerate.
So no secant cube, no plane secant. No
Yeah.
secant with no exponent.
Now watch me put the secant cube as a replacement problem.
Anything
Hey,
else?
another part of the test.
Anything else that you're not?
There will be no nuclear physics on it either. Yes.
What would be like improper problems that involve L'Hopital's? What are we doing that first?
L'Hopital's rule will be used heavily as it's coming up, so you might want to review it. I hope not. So this is like application not to, right? But then what are you going to do when it shows up in a lecture right after the test? Because after the test we have lecture, right? So you might want to review it and learn it. Why did I put the improper integral to be red? It sucks so hard. Yeah, because it's everywhere. That is the correct response. Any of these problems could easily be improper because improper integral is not a new method of integration. Improper integral is a procedure of how to deal with the with the improper integral. The method that you will use to solve integral itself is any of the methods you have 1 through 5. Improper has to deal with that additional procedure with the limit, right? Improper integrals are tricky because it's new for you and you are not used to. It's not impulse still within you. There is no impulse that says, oh, this is a definite integral. I must check for improper integral before I even attempt looking which method to use. We know how to deal with methods in order because hopefully you studied that, right? You always say, is it basic? Nope. Is it U sub? Nope. Is it right? And then you go down the list. And we all know how well that quiz went, right? Yeah, we do, right? So that quiz was designed for you to develop this particular skill where you go, is it U sub? Because if it's not U sub, then we go, how about trig sub, which is far more annoying than a U sub every time. Well, improper integral is another layer on top of everything. So as soon as you see integral with limits, you first have to check if it's improper. Clearly, you know it's improper if it has infinity in it, right? That's no question, right? You see infinity, you know it's type 1 improper integral, hit it with the limit, and then go and do the rest. The issue is what happens if the integral is from 2 to 5. This is what you must develop in this class, moving on through your math education forever. You see a definite integral 2 to 5 or whatever, you have to check whether it's improper before you go and ask, is this U sub? Is this trig sub? Is this partial fraction? Because you can solve integrals and not even realize that they are bad until you actually do them, right? Like we talked about 1 over x squared integral, and this is that's worth actually mentioning again. Integral from -3 to 5 of 1 over x squared dx, and I'm writing it in red, it's just color of blood, right? So this one diverges. The answer is infinity, right? But if you don't spot that this is improper integral, you are going to get a number which is a garbage answer. Because very simple, right? You look at this and what's the integral of this? It's 1 over, right, -1 over x. Is it? Right? -1 over x. And you just need to plug in -3 and 5. And you see how quickly hell breaks loose, right? 1 over 5, minus and minus will give you a plus. No, minus and a minus and a minus will give you minus, and you have 1 over 3. You can compute this and get a number, but it's garbage, right? Because there is, at 0, there is a vertical asymptote. And if you try to compute at 0 as a vertical asymptote, you get infinity. And that's when it blows up. So this integral diverges if you break it apart. So you have to be on the lookout for these vertical asymptotes at all times. Sure, this is -3 to 5 is not going to affect you if it's a trig integral, if it's exponential, or any of those that does not have a vertical asymptote between -3 and 5. But this question does. And this is why questions like this tend to be very scary. And this is actually in engineering, later on, stuff that makes your batteries do interesting things when they're not supposed to. Because if you don't catch, because what's an integral can easily compute accumulation of energy. And what is the explosion? You try to accumulate infinite energy over a small period of time. That's the definition of it. So that's the part that you have to pay attention if you want to be in this field, right? So improper integral lecture fundamentally changed your life from that point on for definite integrals forever, right? And that's why it's red. Yes?
So what you're saying is, yes, you can answer this just fine with -3 and 5, but the problem is in sort of in the middle where you try and put 0 in there, and that doesn't work.
Yeah, so well, this problem cannot be solved this way. The proper way to solve this problem is to say this is -3 to 0, because you know there is an issue there, plus 0 to 5, 1 over x squared dx, and this is where you say it's type 2 improper integral because of the vertical asymptote that happened at 0. And because of that, right, you go and you do the limit, right? You do the limit at 0, and you don't even have to do both integrals. You just do the first one, that one is going to explode. The second one will also explode, but one of them going to infinity is going to ruin everything. So as soon as you have the first one, limit b goes to 0 of -3 to b, 1 over, well, you can write it as x to the -2 dx, right, which will eventually lead into limit b goes to 0 of -1 over x from -3 to b. There's your b going where x is 0, 1 over 0 infinity, and done, right? So this is what you have to be careful. And you know, the question might look so good for U sub, so good for by parts, so good for partial fractions. Partial fractions are the scariest, because partial fractions always have, well, not always, but they are so nicely set up for this trap. And that's and it's very easy for me to abuse that idea, right? Just to see if you are careful enough to check for improper integrals, because you all are going to jump right into knowing that, I don't know, 5x minus 3 divided by, I even because I'm so nice, right? I go x minus 2, x plus 3, and no, that's enough. Just two linear terms, right? They're awesome. And I want that from 0 to 5. Right? And you go, ooh, I know, partial fraction, right? You decompose everything and you just gonna, but look at, where's the vertical asymptote? At 2. Right in the middle, right? Between 0 and 5. Here, in blood. VA, x equals 2, your interval 0 to 5. Right? So it's improper. Sure, you will be, oops, where's my dx? Who lost points now? Who lost points?
You did.
No, I can't lose points. So yes, you are going to do the whole partial fraction decomposition thing to solve the integral, but you actually have to break this 0 to 2, 2 to 5, and use partial fraction to solve 0 to 2. If that one explodes, then the other one doesn't matter what it does, right?
Well, see, that's the piece I don't understand. If one of them explodes, Then the whole thing is divergent.
Yes, because the option for the other integral is to converge or diverge, but the first one is already infinity. So you'll be adding in more to infinity, or you'll 3 to infinity, it doesn't matter, right? It's gone already. So this is the part where you have to be very careful on the next exam, very careful on the final, very careful in Calc2 differential equations and every next course that you might have to take because of these kind of things. Once you are up with the improper integrals, improper integral type 2 might be lurking, places, and you always have to expect it. So grow another set of eyes. I don't know, back. Yes, I think I said everything I had as the intro to this. So 10 problems, possible replacement question, definitely 2 parts of fraction decomposition. One will just say setup, so read. The other one will be fully solved. Whether there is going to be a single standalone trig question or not, there's going to be trig sub 100%, but so it will utilize trig. I'm not sure. One numeric, one of the 3. So you know those formulas. Differential equations, again. For differential equations, you have separation of variables. So if you know that procedure, that can solve 100% of the section we learned, because we only learned the definition, what a differential equation is, and we learned the separation of variables. Now they did give you also a solution for linear first order differential equations, which you can memorize, but you can also use separation of variables if you don't want to memorize the formula. Obviously, it will take you, 5 minutes or so to solve. But if you memorize the formula, just use the formula. You have to be careful with those formulas, guys, because if you're using a formula and you mess up on a formula and there's no work for partial credit, right? So that's the bad part about it. You memorize the formula and then you use it completely wrong, and the solution doesn't match. The cool thing about differential equation is, again, you can plug your answer into the original differential equation and check, right, whether it's right or wrong. Again, that depends on your interest in how well you're doing while you're at the test. You can ignore it 100%. I think I covered everything on that. Questions, concerns, anything?
Can you, the differential equation thing, I'm reading the notes and I'm not getting it. I don't know what I'm not getting, but I'm looking through the notes and I'm looking at them and I have no clue what he's saying.
Okay, so you want examples?
Yeah, you could use some examples. That would be very helpful, because then I can take those and
Okay.
you sit next to the notes and figure things out.
So let's do some differential equations. I gotta get to the textbook. All right, so for differential equations, we said that differential equations are equations which contain functions and their derivatives. And the answer for differential equation is a function. So we are looking for the unknown function y. Y is f of x, right? And we can check differential equation by plugging those back in. So I will do an extremely basic, simple example, and then we'll do another spicier. Differential equations. Chapter 7. These are called warm-up initial value problems. So this would be something that it's considered extremely easy. Problem number 18, let's say, gives you that the derivative y prime is equal to 8e to the minus 4t, and plus 1. Oops, there's a plus 1 there. And then they say that y of 0 is 5. Yeah. So the way these questions are solved is we are going to write this y prime as dy dt using Leibniz notation. And then we're going to take this dt and ship it to the other side of the equation, because this is where this is how we do the separation. So all y's on one side, all t's on the other, and we do have e to the t on the right hand side. Now this plus 1, it doesn't matter which side it's on, so we'll keep it there. So we get separated equation, which is dy is equal to 8e minus 4t plus 1. If you're following notation properly, you will put that in parentheses, because this dt multiplies both exponential and plus 1. And now we integrate both sides. So that's the method of separation of variables. You separate variables, and then you take the y's on one side, t's on the other, and you integrate both sides, which will get rid of these dy and dt parts. So integral of dy is just y, and on the other side you have to integrate these functions. So you have 8e to the minus 4t divided by minus 4 plus t, and then you will have plus c. You can put plus c only on one side. There is no need to go plus c1 here and then plus c2 on this side, and then, right? Because they all combine, all of these constants combine. So we just have one major plus c. And we can simplify this into negative 2e to the minus 4t plus t plus c. And this is something that we would call the general solution. Because it has this plus c. Now recall that we also had a condition y of 0 is 5. So this is initial value. And you can use it to calculate the value of c. Clearly that all of your t's are zeros and all of your y's are 5. So you will plug that in, and you will say 5 is equal to negative 2e to the negative 4 times 0 plus c, because each t is 0. And so e to the 0 is 1. So we have 5 is equal to negative 2 plus c, from where clearly c is 7. So now we have that y is equal to minus 2e minus 4t plus t plus 7. This solution now, when you found the value of c, is called the particular solution. And it's called particular because it is linked to the initial point. It goes through the point 0,5. So this is a particular solution.
I have a question.
Mm-hmm.
We've got 5 equals 2, well, I'm not there yet. I don't understand how you got from the 5 equals.
There's a y.
Right, what's the second one? 5 equals negative 2 plus c.
Well, I just solved. So you understand the substitution, right, part?
Yeah, I get that you're substituting.
Well, now I have 0 plus c is c.
Okay,
That's that.
okay.
And e to the 0 is 1. Negative 2 times 1 is negative 2.
That's what it was. All right.
Cool. So they call this warm-up initial value problems. But since you love this stuff so much, how about you do one?
I didn't say I loved it, I said I didn't get it. Difference, you know.
I know.
It's a good thing both of us have a sense of humor, huh?
No, it's important to have sense of humor at all times, especially when it hurts.
I'll keep that in mind when I test it on Wednesday.
So we have another separable differential equation. You will do it the same way. You will move the dx and then find the general solution with the plus c, and then you will use the point at the end, pi over 2 and 8, to come up with the value for c. Oh, I took more than 5.
For this one, you would have to actually solve it, right? You cannot use the formula.
Yeah, this one you actually have to solve because it's not linear, right? It has cosine of cosine. Beautiful. Okay.
Here. Here's some. You need more? You need more, I got a whole bunch here.
I'll put all of it.
Are you having paper too?
No. I have a whole of it.
Well, you had the sufficient time for this one, right? So we have separation real quick. dy 3 cosine 2x plus 2 sine 3x everything dx. We integrate both sides. Y is equal to integral cosine is sine, so we have 3/2 sine 2x minus 2/3 cosine 3x.
Why minus?
Integral of sine
Oh,
is
it's the
negative
I forgot it was
cosine.
negative. That's why, but other than that, it was great.
So this is the general solution. We will use y of pi over 2, so 8 is equal to 3/2 sine of 2 pi over 2 of pi minus 2/3 cosine of 3 pi over 2 plus c. This one is 0. And then cosine of 3 pi over 2 is negative 1. And this, so we have 8 is equal to 2/3. Wait, cosine of... Oh, yeah. Oh. Yeah, I'm just... yeah, you're right.
Stop for a second.
And then 3/2. So you said for a second, all right? And I
This cross out go to 0 thing always throws me off.
all right. So, well, sine of pi
Yeah, plus the-
is 0.
Sine of pi is 0.
Mm-hmm.
The 3/2 is left out. Okay, all right. And then cosine of 3 pi over 2 is 0. That's all right. That keeps it. All right.
What was the problem?
You forgot to zoom in.
Oh. Zoomed in.
Should we get back down so I can see?
I gotta use these glasses.
No, I got it.
All right, great. So this would be differential equations. We first come up with the general solution, which will have plus c, and if we have initial point, we'll find those. Yes?
What is the linear form? Why do you use like c e to the power minus? Why can't you just do the integration?
You can. It's just much more convenient to memorize the formula and then use it.
Okay.
Because as a student, yes, you will use integration by pi. Well, actually, that's the next problem. So I wanted to address that one as well. So for the next problem, which is first order linear differential equation, you can either memorize the formula or use the whatever. Yeah, sometimes I can't remember words. Yeah, I'm thinking a lot of stuff. A lot of stuff is, you know. Separation of variables, there we go. Yes. For those who are listening, I am in my late 130s. So let's take a look at problem 24, which says dy dt is equal to 2y plus 6. So we could use the formula. But then we can also do separation of variables by saying dy over 2y plus 6 is equal to dt.
Why is they called separation of variables?
Because the variables y are separated from variables t.
That's what that's referring to.
Yes. So we use the separation of variables, and now we're going to integrate both sides. I hope that you all see the ln happening on the left-hand side, right? So, well, we can use u sub, right, where u is equal to 2y plus 6, you know, to be official. dy is equal to du is equal to 2 dy, and we don't have 2, so we can fix that like this. So now I have 1/2 integral of du over u is equal to t plus c on the other side. I integrate. And that's going to be 1/2 ln u, absolute values, don't forget that, is equal to t plus c. Now we're going to multiply both sides by 2. We'll get ln absolute u is equal to 2t plus, and I'm still going to call it c, because the 2 gets absorbed, times 2 gets absorbed by constant c. I remember talking about that in the great detail when I lectured, so go back and watch the video again.
Can you just say what you were saying?
Go back and watch the video again. When I multiply both sides by 2, it should be 2t plus 2c. But c is a constant that we don't know, so this times 2 gets absorbed. And if we have the initial point, we will be calculating that c. So that 2 will not affect it anyway. We e both sides now to get out, yes, u. U is also this 2y plus 6, right? So we get this. So 2y plus 6 is equal to e to the 2t, and then we have plus c in the exponent. So 2y plus 6 is going to be e to the 2t times e to the c, and this e to the c I can call something else, like, I don't know, capital A, whatever. We can pick any values, letters. So I have a e to the 2t. It will be minus 6, so y is equal to a e to the 2t minus 6 over 2, which is 3 when you subtract, so that's 3. So here it is, the general solution, y equals a e to the 2t minus 3 in this case. And that's a general solution because we don't know what the value of a is, so general gets absorbed. Anytime when we have a constant, so either c or a, remember that this a came from e to the c, right? So no matter what I do to this c, whatever form it takes over time, it is going to be, so I don't have to write a over 2.
What were you saying about A over 2?
I don't have to write a over 2, I can just write a because it gets absorbed. A is a constant. That c, like e to the c, now we call it a, it's still going to get absorbed.
Why are you calling it A? That's the piece I didn't get.
At this point, I'm going to ask you to pick another letter that you
It doesn't
don't
matter.
have a
You're just
pet peeve about.
consolidating it into another thing, so it's instead of being an E to a something, it's just an A.
Yes.
Okay.
Because E is a constant, C is a constant, right?
So like you can say it's A over 2, so we call it B.
Sure. I could have started with C1, C2, C3, C4, C5, we are at C6 by the time we're done. You can just drag C throughout.
We'll do the that.
Exactly. Are we good on differential equations?
No, but that's right.
Yes, until we take the course, and then.
This, I think, clears a few things up for me that I was not understanding from the notes.
Awesome. Yes.
I think it's the last problem on in 7.9 that has B. I think it's from 40 or something. How do you separate that?
Okay. There goes the exam question.
What was it?
I have to pick something else.
We're supposed to go home in 20 minutes and then go to that class.
We're
You
doing
go around and change the
overtime
times.
tonight. We're doing overtime tonight.
I have nothing going on.
I
I love being here.
I have an Apple Watch, so I have the right time.
Okay. So we might be familiar with the formula from algebra, which says that x to the m times x to the n is x to the m plus n, and x to the m divided by x to the n is x to the m minus n, which is exactly what's happening over here. Right? Right. So dy dt is equal to 2 times e to the 3y divided by e to the t. Separate the variables now, and let's solve some integrals. You have 18 seconds.
E is also going to absorb the L as a method of
You mean LNC? Yes. I'm sorry?
this is going to be C, right?
Yeah, or you can call it A if you want to change, but yeah. C1, C2, C3, or just C, 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 whatever. Yeah. Because as long as you are changing, as long as the variables are not involved, right? Log is just like working addition, multiplication, whatever. It's another operation.
I'll do Y.
Is this correct?
What would answer?
Can you scroll into the whole thing, because I think I missed something.
I'm sorry?
Forgot what that is. Just continue there for a second. Okay, I was not losing my mind, all right.
Now, how do we know that this is perfect? This is great. Yep. All we need to do is to take the derivative and plug this in the differential equation. If it gives us the true statement, it's good.
Can you go over
Over what?
this?
The problem?
Yeah, because I can't see, well, it kept, when you brought it back down, you bring it down far enough, so I can't see what's going on.
So first we separate variables. Y is on one side, t is on the other.
Okay.
We introduce integration on both sides. We integrate, and then I multiply by -3. Then I ln both sides to get rid of the ln on the left-hand side.
And then the rest makes sense.
And we end up with the general solution. The general solution cannot be broken because this form doesn't break. It's ln of x times y that breaks, not x plus y. So this cannot be simplified any further. At this point here, I'm using the initial point y of 0 equals 0 to compute the value for c, which gives me the particular solution at the end. Of course, man. Now, we do have a differential equation, and I want to check this because let's say I'm interested in, how well I'm doing and so on. So differential equation is y prime is equal to 2e to the 3y minus t. Well, I have y. This thing right here will plug for the y right there. Right? What I don't have is the y prime for this side. So I have to differentiate this y first. That will go here. And then I will take this solution and plug it there. And algebraically, this has to equal left side, right side. And they have to be the same. And then we know it's correct. So the first step for me to check this is to figure out y prime looking at the solution. So I have negative 1/3. And then I have ln. Well, ln is copy the function as is and take its derivative on top, which is going to be negative 6e to the negative t. And if we simplify this, I get positive 2e to the minus t over 6e to the minus t minus 5. Because like 6 and 3 cancel, negative and negative is positive. So that's it. So what do I need to prove? What do I need to show? I need to show that 2e to the minus t over 6e minus t minus 5 is equal to 2e to the 3 times y, and y is minus 1/3 ln of 6e to the minus t minus 5, and then minus t. So I need to show that these two sides are exactly the same. Well, first I can immediately cancel 2's, because they don't bother anyone. And then I will go on, leave the left-hand side as is. And I'm still asking myself if that's the same. And on the right-hand side, when I distribute this 3, that will cancel. And I will get e to the ln of 1 over 6e to the minus t minus 5, everything minus t. Now, why is it 1 over? It's because there was a negative 1 over here. Hopefully you can see it once I erase this. There is a minus 1 there. That negative 1, when 3's are canceled, that negative 1 remains as the exponent and then makes a reciprocal there. So now I have to split these two because I can't cancel e and ln because of the negative t over here. So what I have to do is I have to give e to the minus t. So this one has to get its own e when it's split. So e minus t over 6e minus t minus 5 should be equal to e ln 1 over 6e minus t minus 5, and then times another e minus t, because I am breaking this apart. Maybe if I bring this minus t over here would be easier to get that. I don't know. And now these guys get to cancel. E minus t divided by 6e minus t minus 5. Is that the same as e to the minus t over 6e minus t minus 5? And the answer is yes, it's the same. Therefore, I know that the differential equation solution is perfect because, as you can see, I plugged the solutions back into original equation and solve it. Now, we will all agree that this is much more involved, far more annoying than checking if you had your x plus 2 is equal to 5 and then minus 2, x is equal to 3. And then you say 3 plus 2, is that 5? 5 equals 5. So here is your separation of variables and getting the solution. Here's you plugging the answer back and making sure they equal. It's just this is a little bit more spicy than that. But I can't say the level is the same. The concept is the same, all right? So whatever mathematically you use as a concept here, you solve the equation, you take the solution, you plug it back in the original equation to check the answer. You do the same thing for differential equation. You plug y for y, y prime for y prime. Now your solution is always y. You will have to find y prime. Take differential equations course, you will do the second order, the third order, and so on, which means you have to find, your answer will be y, which is the function, but then you have to find y prime and y double prime and plug them all back in, and then you turn the notebook sideways to fit the expression in 2 lines, to cancel all the terms and so on. So, you know, concept-wise, the same thing, But obviously, calculation-wise, this is far more computation, more algebra, more rules. We also have to do derivatives and everything, where this doesn't require it, obviously. Cool? Speechless. That's how Sunday mornings look like.
Can you make sure you post this tonight, because I wasn't able to keep off writing it, so I'm just gonna,
Yes, you will. You will make sure, right?
I'll make sure for you.
Exactly. How can I do without you?
Well, we're gonna have to figure it out pretty soon.
I'm trying to make her take calculator, but she won't listen.
Do I look like I'm crazy?
Yes.
He said.
I just wanted to calculate.
He'll do whatever it takes.
No, I don't need it. I'm gonna be taking that nice, easy statistics course.
That one live. That one live. Whoever's teaching it will probably gonna now immediately know.
Relative to this, it's gonna be,
Oh yeah, it's Calc2, so yeah.
yeah. I'm looking forward to that.
No. I mean, there are certain aspects of class, like you have to add numbers and divide by 7.
Add numbers and divide by 7, that's
Yeah.
easy.
You have to use calculator to add those seven.
I'm sorry, what?
You have to use calculator to add those seven.
Yeah, it's gonna be hard. Can't
All
wait.
right. Do you have any other questions? Or if yes,
But if you give partial fraction decomposition and you have a quadratic in the denominator that you can't factor,
that's basically what it is.
it's
Rule number 3.
You have, yes, it's rule number 3, so it is ax plus b divided by the quadratic you have. So that's the third one.
I can't think of what to do after you said it. I'm getting away with that.
Well, the same like with any others. Should we do an example of that?
Sure, that sounds great.
Look to that.
Look at my awesome mood today, huh?
Such a nice guy.
Oh, I was born and raised.
Your mama done raised you right. They used to say
Oh, that one.
Like say factor out
in
an x
proper
and then
English.
x becomes the linear and the other thing is the other thing.
You can't factor, you said. If you can't factor, then you can't factor. Also, guys, one thing that is extremely important for you to understand across the board for partial fraction decomposition, you can never use partial fraction decomposition unless you have at least 2 any kind of factors in the denominator, all right? So if you just have over x minus 2, there's no partial fraction decomposition there. You're decomposing over what? X minus 2 and what else? So there should be a common sense that you must have at least 2 things going on. So this is the least of the setup, or maybe x times this, right? But you cannot have over x squared plus 1 and expect partial fraction decomposition there. This doesn't factor over real numbers. That was the dramatic effect. Yeah, it doesn't factor over real numbers. Therefore, it is a single setup. There is nothing to do partial fractions over because it's just a single term, right? I mean single factor. So for partial fraction decomposition, at least you must have, let's say, this or that or anything else that you can think of, but you have to have 1, 2, and then you can have 3, 4, 5, 6, whatever extra in order for you to do partial fraction decomposition. So now that being said, we're going to jump into partial fraction decomposition section and enjoy some of the wonderful problems with irreducible quadratics.
Can you make it improper?
We'll do a separate one that's improper. How's that? Do one that's plain and one that's improper.
Yeah.
Because otherwise it's really going to confuse.
Let's start it as a differential equation.
Just make the test one question without it.
No.
Just make it either or.
Guys, it is actually within the realm of possibility to start the question as a differential equation which works into partial fraction, and in order for you to solve the partial fraction, one of the parts goes into trig sub, one branches into u sub, one branches into. It is very possible to do something like that.
Like either or. Either like the whole.
How many of you would like one problem exam with all of these? We have 2. You guys are doomed.
Can we get an option?
Yeah, there's no say either or.
Pressure's a privilege. That's what my father tells me.
Your father's out of his mind.
They went live too.
That's okay, I don't mind.
Irreducible quadratic, problem 46. It is a vanilla problem, which means straightforward. There's no improper or anything like that. We have x plus, well, z plus 1, but I'm going to use x plus 1 because z's and 2's and life becomes difficult at that point. So this is how the problem looks like. And is this what you desire? Irreducible quadratic, you can't factor this one.
Okay. Yeah.
Awesome. So the first one is linear. Remember that you have to have at least 2. And then plus bx plus c for irreducible quadratic. And now we have the partial fraction decomposition. So we're multiplying, cross multiply. So we have ax squared plus 4a plus bx squared plus cx is equal to x plus 1. A plus b times x squared plus cx plus 4a is equal to 0x squared plus x plus 1. Note my use of the placeholder term right there to make sure that we know that a plus b is 0, that c is equal to 1, and the 4a is equal to 1, from where a is immediately 1/4, bringing it back there to say that b is negative 1/4. So now we have our integral 1/4 over x plus negative 1/4 x plus c, which is 1, divided by x squared plus 4, everything dx. So let me go through the partial fraction decomposition one more time. We have a linear term x whose setup is a over x. This would have been x minus 2, x plus 7. They all have the same setup. It's a linear term. This happened to be x minus 0 or x plus 0. So they all have the same setup. Irreducible quadratic. If this was a minus, it would factor, right? X minus 2, x plus 2. Be careful about that stuff. Then you will have 3 linear terms. You're done. But x squared plus 4 does not factor over linear terms. So we have x squared, so bx plus c. And now we cross multiply. So ax squared plus 4a. And then you have x times bx. And then c times x equals to this one, right? Denominators cancel across the board. And then collect x squared terms on a pile. Collect x terms on a pile. Collect constant terms on the pile, set them up
x squared, x and a constant. So a plus b is 0, c is equal to 1, and for a, which is the constant term equals to constant term, 4a is equal to 1. A is immediately 1/4. 1/4 plus negative 1/4 gives us 0. And we have our integral. Now, integral should be fairly quick, right? In terms of solving it, what do? First integral is ln. So we use 1/4 ln x, well, 1/4 ln absolute x. And then what do we do for this one? We separate. Very good. So we are going to separate this over two integrals. So we're going to have plus integral of negative 1/4 x divided by x squared plus 4 dx plus the integral of 1 over x squared plus 4 dx. How do we solve these two integrals? Very good. The first one is the u sub, and the second one over there is the tangent inverse, which you better memorize, otherwise you're doomed. Yes. Yes. Very good. So we have 1/4 ln absolute x. We are using u sub on this one, so u is equal to x squared plus 4. du is equal to 2x dx. I don't have a 2 over there, so that's going to be 1/8. So minus 1/8 ln of absolute x squared plus 4 plus 1/2 inverse tangent of x over 2 plus c. What a wonderful example. Welcome to Calculus 2. Guys, use this stuff, I beg you. There's Calculus 2, use it.
Oh.
Use it while you talk to regular people, okay? Bring it up, casual conversation, you know what I mean?
Oh, I do.
Exactly. Share the knowledge.
Yes, let's-
Let the world know how superior you are.
I'm sure I'll be just the life of the party on December 3rd. When I go to this house party and start talking about calculus, then I've got lost my mind.
Exactly.
Oh, 1/.
Maybe I should box this, right? Because that's the answer. So that was a partial fraction decomposition. We need high spirits over here. It's calculus
And
class,
so I just break these up and turn these into homework.
I guess. Any other questions for the impending?
She wanted everything to be proper, right?
No? Yeah. All right, so let's do another one of these. So integral of dx over x squared minus 9 from 0 to 3. We'll deal with the stuff later. We'll deal with the stuff later. The improper integrals. We'll deal with it. Just don't worry about it. Just do it.
He just did. Are you guys doing the problem or just messing around? Oh, it's all good. Just take the derivative. It's clear.
Anyone wants to go to Rutgers? No? So I've got the photo from one of the students who graduated last semester. And the bus leading to the left of all the students that are in it. Where did you go? So there's no way you can 5,000 stand like this in the bus. Take the bus 30 minutes to the parking lot to the park. So they can drive an hour home. Awesome. So proud.
I mean, for this, it's nothing. If we have like long. Yes, I was just saying that like, if it's like a big equation, like not just one part, like this and pi after that.
Yeah, you solve the well, yeah, you solve the problem term. You solve the problem term, and the problem term is this, right? Use the problem term and directly you have to make this equal to 24. You have to give the answer 7 or 5 or 10.
Yeah, but like if that x goes, then
Yeah,
alright. So we don't have to like solve this whole thing.
sure, why not? Yes, this problem can be solved either by trig sub, if you want to, or by using the partial fraction decomposition. Sure, either or.
I just like and cancel. I mean,
I'm not going to be looking at it.
I'm just gonna leave like this on the test. Just read it.
Amen.
I'm going to take the test. Yes.
Can you explain to me what you mean by that's the core? That is the inverse tangent is that. I missed it somewhere. I'm not sure. Oh, that's, yeah, no, I'm seeing it in my head.
That's the formula.
Thank you.
No.
X squared plus A squared.
Yes.
When we're doing differential equations, are we like multiplying by dx or are we integrating with respect to x?
Yeah, well, it's times dx, but it's integrating in respect to x, yes.
Like if you didn't multiply, you just integrate both sides and the dx is just cancelled.
Because dx is the, for the integrals, dx is the width. For those rectangles, function is the height and dx is the width. Integral just means addition. So you have to have dx on the same side where the integral is.
So when you integrate, dx has to be there. What's the difference between differential equation and implicit differentiation?
Well, implicit differentiation is the way to differentiate expressions which are not functions, implicit relations. Differential equation is the equation where the function y is unknown and you have to find it. So it's completely two different things.
So it's improper, and you just have to figure out whether or not.
So this is one of the improper integrals. Oh, look at that, it's almost 9 o'clock. So we have the pen die for the first time
For the first time.
tonight.
I was gonna say, really?
So we have this factor over x minus 3 times x plus 3, but we see that the vertical asymptote
is at x equals to 3, which makes this type 2 improper integral, which means that I will have to solve it as the limit b goes to infinity of integral 0 to b dx over x minus 3 x plus 3. So that's what we have to do. Now you will use partial fraction decomposition, or you will use the trig sub, whatever it makes sense. Yes?
Why did you do b to infinity instead of b to 3?
That's what I said. It's to 3.
Oh,
Yeah, that's what I was saying.
Yeah, it's 3. It's clearly 3. Do I need to zoom in?
please. Oh, oh, it was just sideways.
All right. I'm glad we resolved that. No, anytime you have any questions, I am very accepting. Now we're going to set up the partial fraction decomposition as a over x minus 3 plus b over x plus 3, everything dx. And please note that every time you drop a limit, it's -1, which means that you can lose 15 points per problem. It's point per line per limit, right? So yeah, 10 steps minus 10. If the problem was 6 points, then yeah. Partial fraction decomposition is ax plus 3a plus bx minus 3b is equal to 1. And we have a plus b times x plus 3a minus 3b equals to 0x plus 1 placeholders. I have a plus b to be equal to 0 and 3a minus 3b equals to 1. So I will multiply the top one by 3 and get, when I add, that 6a is equal to 1, from where a is 1 over 6 and b is immediately negative 1 over 6. We start with the limit b goes to 3 of 0 to b, and then I have a, which is 1 over 6 x minus 3 plus negative 1 over 6 over x plus 3, everything dx, which is further equal to the limit b goes to 3. We have 1/6 ln x minus 3 minus 1 over 6 ln x plus 3 Now we are going to combine these, right, because we still have to do 0 to b, right? But I'm going to combine these two limits together. Sorry, these two ln's. So I will factor 1 over 6 in front of the limit, and the ln's will be ln of x minus 3 divided by x plus 3. Just make sure that I have all my signs correct. So minus, 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 minus. Excellent. That's it.
So now we are computing from 0 to b, and the next step is 1 over 6 limit b 3. I have ln of b minus 3 divided by b plus 3, and then when I have 0, it's ln of 1, so minus ln of absolute negative 1. That thing goes to 0, so we don't care about that one. The problem is that this one explodes on the left, because you have 0 over b plus 0 over 3, and 0 over 3, it's negative infinity, so it diverges. Yes?
We take points off if we stop earlier or don't write all that out.
What do you mean stopped earlier? Then you didn't finish the problem.
Well, we didn't do it.
The problem is done when you say it diverges.
As many steps, maybe.
No, you do as many steps. I wanted to explain everything because I'm an awesome person. Don't get me wrong. When you plug in 0, you have negative 3 divided by positive 3, which is negative 1. Absolute value of negative 1 is positive 1. ln of 1 is 0.
But what if over there we realize that there's going to be 0 and we just say diverge?
What can I say? Just do it.
What if we get infinity and
We'll say the stream